Hi, today's video discussion is about some important terms related to the study of waves. After watching the video, we hope to identify the different parts of the waves and classify waves based on the direction of the particle displacement or based on the medium needed. So if you're ready and you have your learning activity sheet with you, then we can start with our discussion. Waves are considered carriers of energy. They are actually disturbance that transfers energy. Because energy is transferred from one point to another, a medium is needed. So this medium is a material, so it can be a solid, a liquid, or a gas, that material through which a wave travels. In this painting by Hokusai, The Great Wave of Kaganawa, we see here a big wave of the open sea. So this painting shows how much energy this wave carries, and this energy is transported from one point to another using water as the medium. A wave has different parts, and in this diagram we see that there are 5 parts. The first part of the wave is the crest. A crest is considered the high point on a wave, while the trough is the low point on a wave. Also, you see here a horizontal line, and this is the rest or the equilibrium position. And using that information, we can measure amplitude, because amplitude is the measure of the distance the wave vibrates from the rest position. So some waves will have very high amplitude, while some waves will have very low amplitude. Talking about that, amplitude is also considered a measure of strength. So this means that if a wave has high amplitude, it means it carries a lot of energy. That's why it's considered a strong wave. Now, aside from amplitude, the wave also has a node, and it is a point where the wave has minimum or zero amplitude. In our diagram, you see that the node is located on the rest position, meaning it has zero amplitude, and that is how we define node. A wavelength, which is denoted by the Greek letter lambda, is a measure of a full wave. So this means that in order to identify wavelength, it can be the distance from one crest to another crest, or it can be the distance from one trough to another trough. So that's how we measure wavelength, which is denoted by the Greek word lambda, Greek letter lambda. So waves can be considered transverse or longitudinal, and it is based on the direction of the particle displacement. So let me write it down first. So you have transverse or longitudinal. Now, using these diagrams as our guide, so we see here that a transverse wave have particles where they move perpendicularly to the direction the wave travels. On the other hand, for a longitudinal wave, the particles move parallel to the direction the wave travels. Now, let's try to recall the different parts of the waves using this diagram. So for a transverse wave, because it goes up and down, because it moves perpendicularly to the direction of the wave, we see here the crest or the trough. Now for the longitudinal wave, because there are no high points or low points, but instead there are points wherein the waves are compressed or spread out. So the point where the waves are compressed is called the compression area, while the waves that are spread out, it's called rarefaction. So looking at these 4 terms, then we'll be able to measure the wavelength. And just like what we discussed a while ago, for a transverse wave, a wavelength is measured from one crest to another crest, or from one trough to another trough. But for a longitudinal wave, it is a measure from one compression to another compression, or one rarefaction to another rarefaction. So let's try to summarize this. So transverse means that the particles move perpendicular to the direction of the wave, while longitudinal, the particles move parallel to the direction of the wave. So some examples of transverse waves are the S waves we see in our earthquakes, and even light waves. On the other hand, sound waves are a good example of longitudinal waves. So this means that for sound waves, there are areas where the waves are compressed, and there are areas where the waves are rarefied or spread out. Now, aside from wavelength, then we can also apply our lesson on amplitude, because for a transverse wave, it's very obvious that when it has a very high amplitude, then it means that the transverse wave carries a lot of energy. But for a longitudinal wave, because it does not have high or low points, we will look at the compression area. So if the compression area is very compact or dense, then we say that the amplitude is very high. It means that it carries a lot of energy. Now, aside from these two classifications, transverse and longitudinal, we can also classify waves based on the medium needed. So we have mechanical, or electromagnetic. So a mechanical wave is a wave that requires a medium. So it needs a medium to travel. For example, we have sound waves or water waves. On the other hand, some waves do not require a medium to travel, and they are called electromagnetic waves. So no medium. A very good example of an electromagnetic wave is actually sunlight, or because it comes from the outer space and it reaches the earth even without a medium, or light waves. While light waves can also travel with a medium. So this means that, for example, light waves are considered transverse and electromagnetic waves, while sound waves are considered longitudinal and mechanical waves. So I hope that clears out the different parts of the waves and the two classifications of waves. So waves can be transverse or longitudinal. It can also be mechanical and electromagnetic. And when you measure a wave, it's very important that you also measure the wavelength, and it is given by the Greek letter lambda. So that's all for today. Thank you for listening.